Hello everybody, this is GenGift here, and we're back with Turing Complete, actually, because this Turing Complete, I guess you could call puzzle game, is actually involved with designing the central control power grid and building in Minecraft. This is the computer that the game walks you through into designing. And some of the more astute of you will be able to look at this and tell me what is already wrong with it, because there's already a few issues with this thing that make it kind of interesting to program around, but there are a few issues with this thing. Although, mention it in the comments. It'll be fun. So, this is pretty far down the game. The puzzle game kind of thing. So you start with basic logic, go to arithmetic and memory, go to CPU architecture, working computer, and now I am in the programming phase. Now, because the way the thing immersive engineering works in Minecraft, I don't think I'm going to have a UI to start typing in assembly code. Well, I suppose it could be possible, particularly if I decide to tie in computer craft. But at the moment, there isn't really a way to do it. So I'm here at this puzzle here, the Add 5 puzzle. I'm going to be showing you how the programming in the immersive engineering computer for the centralized power grid is probably going to work. And you can tell, here's the instruction. You've built your computer, but to win the competition, you still need to finish the maze. If you don't know how to program that yet, you're not quite ready for that yet. So in the meantime, it'll help you out in the ship a little bit. So the puzzle is to get the input from down here, toss that into register 1, add 5 from register 3 to from register, that's 0, 1, 2, 3. Add 5 from register 2, which goes into the ALU here. It comes down to 3, which then gets sent out over to the output. We don't have to worry about any overflow or anything, just add 5 to the input and do that over and over again. So I could now move these things, because prior levels they were locked into place. You couldn't move them around, but I can freely move them, but I'm not going to. So I've actually already designed this program. I've got a photo of it on the phone, but we're going to start from scratch and enter it bit by bit. So these are the instructions. You can, in here, see what kind of instructions you're putting in immediately. So in this case, this is going to run immediately, which is going to take whatever number is in the program and dump it into register 0. So let's dump 5 into register 0, because that's something we're going to need to do anyway. So we take that, and we'll dump 5 into register 0. Boom. There's 5. Cool. So now, what we're going to do is we're going to take that register 5, the 5 in register 0, and put that into register 2, which requires the copy function, which goes from there to there. So it's a 130. So U, and now if we hit this twice, you'll see that there's now a 5 in register 2. Now we need to get the input. So we need to copy from input to register 1, which is what we're going to do right here. I got to do this to refresh it. Now I've also got to actually put it into the program instead of just starting hitting the next button, but I didn't. So this puts a 5 in register 0, this copies register 0 to register 2, and this will put the input into register 1. Now, we need to add those together. So let's copy, we need to compute, add, so we need to hit this and that, which is 68 in the program. So we hit the next button. Of course, it resets. So 5, copy the 5, bring in the input, add the output, the 5 to the input, and now in register 3 we have 158, which is 153 plus 5 going through there, 158. Now, after that, I need to send that from register 3 to output, which means I need to put 158 in here. And there we go. So, boop, 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 running through the program, and there we go. That test is completed. So now that the computer is programmed, we can just hit this, and it'll run it through each time for the 32 tests we need to do. And now we have finished the first computer program, which is just taking an input from down here, from outside, puts it into, well, first takes 5, dumps it to register 0, takes that 5, dumps it to register 2, brings the input, dumps that into register 1, adds 1 into register 1 and 2 together, puts that to register 3, then outputs register 3 to the output of the computer CPU thing over in the bottom right. And we've tested successfully all of these 32 times we needed to run the test. So level complete. And now I go onwards to the next level here and process this and upload it for Sunday. See ya. Oh, by the way, other news. Remember how I mentioned that my plan was broken from last weekend? I have decided to ignore that problem and make it exactly as I had planned to, and adjust the later substations later on. Because, since it's a programmable computer, I can add an exception for that substation and make it so that it just doesn't do anything with it. Or it can do stuff with it. Because it's things I can still have the computer do with the substation where the design was broken. But we'll cross that bridge when we get there. So I'm going to build the substation exactly as I intended to, as a test to make sure some of the other functionality works anyway as intended. So, don't forget to like, share, and subscribe, and we'll see you next time. Hello, I hope you've enjoyed the video. Don't forget to like, share, and subscribe, and hit the bell icon and all that wonderful fun stuff, because subscribing to YouTube is no longer enough. Hit all the things. Hit the like button. Like the comments. Comment multiple times. And don't forget to share. But subscribe and hit the bell. See you next time. Bye. I think our tank exploded. Whee! There it goes!
The plane or our tank?
Well, there's a tank flying through the sky.